Hello, Math 2 students. I hope you're ready to review for the very last time before the big quiz on graphing quadratic functions. We're going to go through 3 problems right now that will help you out on the quiz. I would suggest that you study finding all of the key characteristics. You need to know all of those vocabulary words on the list of key characteristics and know how to find them and use them to describe a graph. Good luck on the quiz. On this problem, we need to identify the graph of f of x equals 3x squared minus 1. So my a value is 3, my b value is 0 because there's no x term, and my constant term is negative 1. Since our a is positive, the parabola is going to open up, and since our a is greater than 1, it is going to be a vertical stretch. Remember, if it's a vertical stretch, then it will look like it is skinnier than the parent function. Our y-intercept is negative 1. And for our vertex, we're going to do a quick calculation. So we have x equals negative b over 2a. And our b value is 0, and our a value is 3. So that's 0 over 6, which is 0. And then I have y equals 3 empty bracket squared minus 1. When I put the 0 in the empty bracket, I have 0 minus 1. So our y value is negative 1. So our vertex is 0, negative 1. Some of you already knew that because you realize a problem with an a of 3 and a c of negative 1 is just going to be translated down 1 unit. Our axis of symmetry matches the x-coordinate of our vertex, so it's x equals 0. Our domain is all real numbers. And our range, since all of the graphs open up, then we know everything is going to be above our vertex. So all of our y-coordinates are going to be greater than or equal to negative 1. Now that we have all of the key characteristics, we have to find the graph that matches those characteristics. So the first thing that I would look at is I would look at the vertex. And our vertex is at 0, negative 1. Now, that doesn't mean anything unless you know the scale of the graph. So on the graph that they gave us, we have 0, 1, 2, 3, 4. So on the x-axis, they're counting by ones. And on the y-axis, we have 0, 1, 2, 3, 4. So on the y-axis, we're also counting by 1. So this is the best possible graph. Every square is equal to 1 in the x direction and in the y direction. So our vertex is at 0, negative 1. So our vertex is at 0, negative 1. That would be there. On the next graph, 0, negative 1 is there. On the next graph, 0, negative 1 is there. So this graph is definitely out because it doesn't have the right vertex. And on the last graph, 0, negative 1 is there. So this graph is definitely out. So both of the top graphs have the same vertex. They have the same axis of symmetry. They have the same y-intercept. They have the same domain and range. The only difference between those two graphs is the vertical stretch or shrink. So now what I'm going to do is I'm going to put the parent function on both graphs. So the parent function, here's the vertex. I'm going to put the vertex in the same place as the vertex on the graph. Over 1 and up 1, over 2 and up 4, left 1 and up 1, left 2 and up 4. It looks like this first graph is the parent function. So that's definitely not the graph of f of x equals 3x squared minus 1. That's the graph of f of x equals x squared minus 1. So when I put the parent function on the last graph, the one that's going to ultimately be the right answer is I put my vertex right there, over 1 and up 1, over 2 and up 4, left 1 and up 1, left 2 and up 4. And so our parent function would look like that. And you could see that our blue parabola is narrower than the parent function. So that means that is a vertical stretch. So our a value of 3 seems to be working out. So on the parent function, I would go over 1 and up 1. On the blue function that they gave us, it would look like this. I would go over 1, and since there's a vertical stretch of 3, I would go up 3, and that's where the point is on our blue graph. So the blue graph is a vertical stretch of 3. In the vertical direction, you go up 3 times as much as the parent function. So the right graph to choose on this problem is the top right-hand graph because it has the right vertex and it's a vertical stretch of 3. On this problem, they want us to identify the graph of y equals 4x squared plus 24x plus 13. So our a value is 4. Our b value is 24, and our c value is 13. Because our a value is positive, we know the graph will open up. Because it's a positive 4, we know it's going to be a vertical stretch, so it will look like it's narrower than the parent function. Our y-intercept equals our c value, so that's 13. Our vertex is going to take a little calculating. So we're going to go x equals negative b over 2a, and our b value is 24, and our a value is 4. So that's negative 24 over 8, which is negative 3. So the x-coordinate of our vertex is negative 3. And then we put it into the function, and we have 4 times negative 3 squared plus 24 times negative 3 plus 13, and that will make y equals 4 times 9 plus 24 times negative 3 plus 13. And when we continue this part of the problem, we'll have y equals 36 minus 72 plus 13. And so y equals negative 36 plus 13, which is negative 23. So the vertex on this problem is at negative 3, comma, negative 23. Our axis of symmetry is going to be at x equals negative 3. Our domain is all real numbers. And for our range, this graph opens up. So every point is going to be above the vertex. And our vertex is at negative 23. So every y-coordinate is going to be greater than or equal to negative 23. Now we know all of our key characteristics. How do we determine which graph is the right graph? Well, they all open up. So the first thing that I'm going to check is I'm going to check the vertex. But the vertex doesn't mean anything unless you know the scale of the graph. So on the x-axis, we have 0, 1, negative 2, negative 3, negative 4. So on the x-axis, they're counting by ones. That's great. On the y-axis, it's 0, 5, 10, 15. So on the y-axis, they're counting by fives. So if our vertex is at negative 3, comma, negative 23, we're going to go 3 spaces to the left, and then we're going to go down 23. So if we're counting by fives on the y-axis here, this will be negative 15, and this will be negative 25. So negative 23 will be somewhere in between negative 20 and negative 25. So our vertex should be about here. So obviously this is not the right graph. If I come to the bottom left graph and I go left 3 and down this one, that looks like it could be in the right place. So I'm not going to cross that one out. On the top right, negative 3 and 23 would be right there. That's definitely not the vertex of that blue parabola. And negative 3 and negative 23 is right there. That is definitely not the vertex of that blue parabola. So on this problem, the correct graph is the bottom left-hand graph. And we know that it's correct because that's the only graph that has the right vertex. It has the vertex negative 3, comma, negative 23. On this problem, they give us the function h of t equals negative 16t squared plus 48t. And they say that that represents the height in feet of a golf ball t seconds after it is hit. The height of a second golf ball t seconds after it is hit is shown on the graph. which golf ball went higher. So on this problem, it's a comparison of two different golf balls. This is the first one, and this is the second one. And they want to know, did the first one go higher or did the second one go higher? Well, if you look at the y-axis of the graph is height. So the y's are height. So if we can find the vertex of this parabola, which is going to be right here, the y-coordinate of the vertex will be the maximum height. So it looks like on this graph that the vertex is at 2 seconds and 64 feet. So the height of the second golf ball is 64 feet. So now if we take the first equation, and we don't even need to graph it, if we could just find its vertex and look at its y-coordinate, we'll know what the graph of that first golf ball would look like, and we can tell if it's higher than the second graph or not as high as the second graph. So to find the vertex, we're going to have to do some calculations. So we go x equals negative b over 2a, and our b value is 48. Notice that that 48 is connected to a t, which is just like the x term. That is our b value. And our a value is negative 16. So we're going to have negative 48 over negative 32. And when I divide that, it comes out to positive 1.5. So that's the x value. So that'd be 1.5 seconds. So the second golf ball reaches its maximum height after 2 seconds. This first golf ball reaches its maximum height after only 1.5 seconds. So now we take the function and we go y equals negative 16, 1.5 squared plus 48 times 1.5. And when we put that into our calculator, we find out the y value, or the height in this case, is 36 feet. So now we know the vertex of the first golf ball is 1.5, 36. So the height of the first golf ball is 36 feet. That is the maximum height. It's going to be a parabola that opens down, and that point is going to be on the very highest point on the parabola. So if the second golf ball had a maximum height of 64 and the first golf ball has a maximum height of 36, which golf ball went higher? The answer to the question is the second golf ball went higher.